Yes, hello everyone and good morning. कैसे हैं आप सभी? So welcome to the lecture where we are going to discuss about reaction, a very interesting topic of organic chemistry, which is reaction mechanism. And I hope you will enjoy this topic and you will learn new things and a new approach about this topic, how you need to study this topic, what are the bifurcations we need to do in order to make this topic easy. So welcome to the live and good morning to everyone. Good morning, KM Dairy. Good morning, Pooja. Good morning, who are not commenting in the live but still watching. So good morning to you also. So I want to clear one doubt. If someone is looking this lecture into recorded form also, actually this lecture is lecture number 1. Due to some reasons, yesterday's lecture was not done, so I was not available. So this is our lecture number 1. I will be starting your topic from the basics, means from the starting portion, how we need to proceed with this topic, and then if time permits, I will cover this topic, that is effect of solvents and what is the effect of solvent in the nucleophilicity and so on. Good morning, Brejraj. Good morning. So this topic is especially for the students who have Hindi language as a barrier. So we have decided you to provide your chemistry as a subject in a complete English medium pattern, so that a barrier can never be a can become a hurdle for you to understand any topic. So this I will try to speak in English throughout the lecture, and I will explain all the concepts in English only. And if you have any problem, you can comment and we can discuss that also. Good morning to everyone. So, talking about organic chemistry, be it any exam, be it CSIR NET exam, be it GATE exam, or any state level set exam, or any, let's suppose, um, any PSU's exam, so or any assistant professor exam. Every exam does have organic chemistry in their syllabus, and reaction mechanism topic uh, do generally have a great weightage in the organic chemistry section. Now, what's the big problem with this topic is we don't get anything in the books directly written as this is the chapter of reaction mechanism. Go through this chapter and you will be covering each and everything. Everything is presented in a very scattered way in all the books. So we need to pick up things from different books and then we need to study it. But no need to worry, I have done that job for you. Now we need to see what should be the correct procedure, what should be the correct order for studying this reaction mechanism topic. So today we are going to focus and we will begin with this topic of reaction mechanism. So now the very important question is how to study this topic. What would be the best way to study this topic? Um, See, this we will divide our topic, this reaction mechanism topic, into fragments, into small fragments. For example, I will show you the chart. Reaction mechanism is divided into three basic reactions. The first one is your substitution reaction. The second part is your elimination reaction. And third part is your addition reactions. Okay, these are the three basic pillar of any reaction mechanism topic. And if you are preparing for CSIR NET exam, some additional things also get adds up. For example, particularly for CSIR NET, I will say one concept is of Hammett equation, upon which CSIR NET do ask questions. So Hammett equation becomes important. So we will add this topic and we will supplement some topics looking at the different demands of the exam. Okay. So please, if you are uh, watching this. Good morning, Pooja. Okay, so we will try to be communicative in the chat section also, because if I am teaching only and you are not responding, then I don't think that will be a very effective way. So please try to respond in the chat section also. Okay. So for example, CSIR net Hammett equation will be added, and one more topic is that is fragmentation reactions. Fragmentation reactions. This topic is also adds up for CSIR net exam, for GATE exam, and for set exam also you can study fragmentation. That may also help you out. So GATE exam and CSR for CSIR net exam, we need to focus on the Hammett equation plus the fragmentation reactions part. Of course, this carries a very huge weightage in CSIR net exam. Always one or two questions is asked from here in the part C section. Now, these are the words which you are familiar with since you were in class 11th. You have seen this for the first time, sir. First lecture है जी बिल्कुल first lecture है. This is the first lecture. So, when we were in class 11th and 12th, when we have heard first time about reaction mechanism, then also we have heard these words as substitution, elimination, and then addition reactions. Good evening, good morning, Zimit. How are you? How was your paper? These are recently added topics, Hammett and fragmentation. We cannot say these are recently added topics, but these are the topics which we need to study for a higher level exam, like CSIR NET and GATE exam. They generally do ask these topics also. But if you are preparing for any state level set exam for IIT JAM or let's say for CUET, then these topics will be eliminated and we will be going through the basics first and then we will cover about Hammett and fragmentation reaction. Okay. See, so substitution is a very common word which we have heard, but there is lot more to know about substitution reaction, how substitution take place, what are the basic elements involved here. So we will look in detail. Now the second is your elimination reaction. Elimination is also bifurcated in many reactions, and then third is your addition reaction. Moving ahead, we will be talking about first of all regarding substitution reaction. See, this mechanism is distributed into six sub-mechanisms. For example, the first one, very famous, each one of you must be knowing about it, that is SN1 reaction. But if we only study SN1 reaction and if we don't compare this mechanism with other like SN2 mechanism or SNNGP mechanism, then we will not be able to crack the questions in the exam. So it's very important to study in a very comparative manner with SN1 and SN2. The second is your SN2 uni bimolecular substitution reaction. We will goes through these mechanisms in very detail. Okay, I'm fine, sir, and you? I'm also fine, Zamir. The third mechanism which we will be covering is SNI. Can anyone tell me what is the full form of I here, or what the I stands here in an SNI mechanism? And then the fourth one, very important for any exam, it be a CSIR NET exam, a GATE exam, any exam. NGP mechanism is very important and highly weightage in this mechanism, or we can say in the substitution part. And third is our SNAE, that is our addition elimination. AE stands for addition and elimination. First addition take place as the name is suggesting us, and then the elimination would take place. And if we are reversing these two, it means the things are going to be reversed. First of all, elimination is taking place and then your addition is taking place. Thing get reversed. Okay. Now, when we will cover once we have covered this all the mechanisms of SN1, SN2, SNI, NGP, AE and EA, then we will be moving to electrophilic aromatic substitution. This is complete whole chemistry in itself, so it is also very important which we need to cover. So while starting this topic, it becomes very important to set, what you can do is you can make some folders in your mind. For example, make a folder of reaction mechanism. In that reaction mechanism folder, create a three subfolders. First of substitution reaction, second of elimination reaction, and third of addition reaction. And if you are a CSIR NET aspirant, then keep a Hammett equations folder also. Now, particularly when you will open, double click the substitution folder, what you are going to see is some mechanisms like SN1, SN2, SNI, SNNGP. You need to create the folders. That's why I'm giving you this flow chart. In this way, we will move through our topic. Okay. Good morning, Sunil. Jay Chaurasia, good morning. Good morning. Intramolecular, yes, very good. Not as good as it should be. 57 marks takes place for OBC. Hmm. Okay, let's see what would be the mm, marking system for this and what will be the highest marks. Okay, but it's fine, Zamit. It's your marks is good enough. It depends the level of difficulty of the paper and how other students have performed in the exam. Okay. Yes, SNI stands for in SNI. This I stands for intramolecular, and of course SN is for your nucleophilic substitution. But this I is particularly called as intramolecular, and you must be knowing about, I think, NGP, that is neighboring group participation. Intramolecular. Very good. And you must be familiar with this, that is neighboring group participation. Now, these are the mechanisms which we need to study. But if I straightforward start with SN1 reaction, then it will be very unjust with you people, because without understanding what is a nucleophile, what are the factors which affect the nucleophilicity of any nucleophile, and what are the basic components involved in any substitution reaction, we cannot understand these mechanisms in a very what we can say in a very complete manner. It's very important to understand the basics first. So without starting these mechanisms straightforward, what would be the best way to first understand what is a substitution reaction, or we can say what are the basic components which are involved in any substitution reaction. So understand this, we will move to the general reactions. First, we will see a very general reaction of any substitution reaction. What we find there is, we see that we have any substrates. For example, let's suppose Rx. This Rx species is called substrate. So the first component which we are seeing is a substrate here. The second component we generally see is a nucleophile. So it is also very important. We will write the second component is our nucleophile. And of course, if the reaction is taking place, you need to have some solvent. So a solvent may also present. Sometimes it may be absent, but most of the time solvent are present. So we may have a solvent also. And once the nucleophile has attacked and substituted, we will have our product. And of course, the living group must have been eliminated. So this is our product and this is our living group. So talking about the components, we have 5 components in any substitution reaction. The first component is of substrate. The second component is of nucleophile. The third component is of solvent, and you must have seen the heading of this lecture was effect of solvent. If you don't understand what is the effect of the solvent in the nucleophilicity, then how you are going to understand what happens in an SN1 reaction, why we choose that type of particular type of nucleophile in SN1 reaction. So it becomes very important to first of all understand what a solvent can do, what role it plays into the substitution reaction. Good morning, Sapna. Good morning, Jay. Good morning to each one of you. I request to please do join the lecture when it starts sharp at 9 a.m. Daily I will be coming live at 9 a.m. and I will be trying to cover this topic. This is particularly I am focusing this lecture for students who face Hindi as a barrier. That's why I will be covering this complete lecture in English only. So, the fourth component which we can see is a product, and the fifth component is of our living group. These are the five basic components for any substitution reaction. Okay. Now, starting from the substrate, let's suppose we have choose our first component, that is substrate. What are the different type of substrates you see in a substitution reaction? You must be familiar with that. So what are the substrates? You may have seen, let's suppose, alkyl halides. These are very common. You must have performed many SN1 reactions, SN2 reactions here. For example, you must have alkyl halide, alkyl chloride, bromide and iodide as the living group. This may be a substrate here. And you may also have a substrate as OH group. But OH, since it's not a living group, you must have converted this OH into a good living group. Then you must have performed SN1, SN2 mechanisms. The third comes is NH2 group. This NH2 is also not a good living group. You must have been converted it into a good living group. If you remember a very famous reaction, you convert NH2 into N2 positive. Can anyone tell me which reaction is this? A very famous reaction where I am converting NH2 to N2 positive. Other substrate which you can accept is a ether here. Of course, you get ethers where you can perform SN1 and SN2 mechanisms. Hydrolysis of ethers, very famous mechanism. And if we talk about cyclic ethers, then we need to deal with epoxide systems. And epoxide opening is a very um, we can say a vast topic, and it has very few exceptions also which we need to cover. So this will be the epoxide portion here. So these are the few substrates which we are going to see when we will be dealing with substitution reactions. So we will be starting this. This is our first component of substrate, and the epoxide is the very important one. That's why we have marked the star also. Yes, very good, Camderi. This reaction is called as diazotization. Diazotization. Can anyone tell me if we have three amines, let's suppose I have 1 degree amine, I have 2 degree amine, and I have a 3 degree amine. What happens if I do diazotization reactions with all of these three? Whether one is going to be converted or whether all is going to be converted into diazonium salt. Can anyone tell me? Because moving ahead in these lectures, I will be covering this diazotization also in a very detailed manner. Then we will be looking at the mechanism also, how diazotization has taken place, what are the electrophiles responsible here. So, but for just a knowledge check, can you tell me whether 1 degree, 2 degree, 3 degree, I mean all is going to be converted or only one is going to be converted? You can answer me into the chat section. Now, the second important component is our nucleophiles. And if we are writing nucleophiles as a heading, it means we need to learn what is nucleophilicity and how we are going to compare nucleophilicity for different nucleophiles. What does nucleophilicity means? Means, let's suppose if you have mm, uh, few nucleophiles. I have given you 4 nucleophiles. Now I ask you which nucleophile will attack on the electrophile with a very high rate. It means I am asking what is the nucleophilicity order. Okay. In exams, straightforward question is asked from this topic, that is the examiner will give you 4 nucleophiles and he will be expecting you to arrange that 4 nucleophiles into increasing or decreasing order of the nucleophile. So it becomes very important. It's very interesting also. So if we need to compare nucleophilicity, then we must be aware about the factors which can affect the nucleophilicity. Yes, Camdari, very rightly said. If we perform a diazotization reaction, only 1 degree amines can be converted into diazonium salt. No 2 degree amine and no 3 degree amine can be converted into diazonium salt. Okay, so this is just for your knowledge. I will be covering and explaining this into detail also. Very good. Now, talking about the factors which may affect, so we will be writing the heading. I request you to make notes properly because these notes will be help they will help you out in each and every exam. Okay. So factors affecting nucleophilicity. Now, what do you think? What factors can contribute in the nucleophilicity? See, the first factor which will be very important to check nucleophilicity is size. Size of the nucleophile matters a lot, whether your nucleophile is a good nucleophile, a bad nucleophile. Okay, so size will be a very important factor. The second factor which may affect is electronegativity. If I write En, it means I am talking about electronegativity. Okay, don't read it as No. This is electronegativity. Very good. The third factor which may also contribute is stability of the anion. We need to understand the chronology also. Why I am writing the first factor as size? Because whenever we need to compare the nucleophilicity, I will check the first factor, that will be size only. Okay. So I will explain you how the chronology works here. But once let me write all the factors which may affect. So the third factor is going to be stability of anion, or the nucleophile or the anionic center which you have chosen. What, how much stable your anion is, that is also going to affect the nucleophilicity. And then the fourth factor which may contribute is hindrance. If the nucleophile is very bulky, then it may not prefer to perform a substitution reaction. That will also may be a factor. And then a very important factor, that is effect of solvent. Effect of solvent. Solvent may also affect the nucleophilicity, and we will see how it works and how the solvents are going to affect the nucleophilicity. Okay. Size, electronegativity, solvent, bulkiness, very good spread piece. These are the factors which contributes towards the nucleophilicity of any anionic center. Spread piece, how was your paper? How was your IIT JAM exam? Okay. So now what we will be starting from the first factor, that is size. Now we will see how size can affect nucleophilicity. Okay. So we moving ahead, we will write our heading as size, because we are going to learn how a size can affect the nucleophilicity. Let's suppose we have a two type of nucleophiles. One, a very small size nucleophile, and one, a very large size nucleophile. And they both are anionic in nature. Very good. Or and we have a center like this. Let's suppose we have a 2-degree center, a R group and R group, a hydrogen here and a X group here. You know that if we have any nucleophile, what it is going to do is attack at this carbon center, and this X group is going to be removed. This is a very basic nucleophilic substitution reaction which we perform, right? Yes, Cam Diary. We can say that ki polar solvents are good for SN1 and non-polar best for SN2. Non-polar is not a right word. You should say polar aprotic solvents are good for SN2 reaction. Okay, not non-polar one. We choose polar one in SN2 also, but there is a small difference between polar protic and polar aprotic. I will be going into detail about the solvents also, and I will give you the examples also. Your concept will be clear. Okay, okay. Why okay, okay? Why not good? What happened? So this nucleophile will attack and the X is going to be removed. This is what we know. Now, talking about polarizability, you must have heard about Fazan rule. If I inorganic, you must have heard about Fazan rule. If I remember, we used to study in that portion only. The Fazan rule says that if the anion size is very bigger, if the size of an anion is big, size of anion is big, so the polarizability is also going to be high. Polarizability is directly proportional to the size of the anion. Correct? What does polarizability means? To understand this into a very layman language, what we can imagine is, let's suppose we have a very big size balloon and it's very easy to compress a big size balloon and change its shape into, let's suppose this may get polarized and it has changed its shape some like this. So this is the meaning of polarization. Means it has been get polarized. Its shape is very easily changed or it has been deformated. Okay. Now talking about a small size anion, because of its small size, its polarizability is less. Yes, polarizability is less because the size of the anion is small. So this, how does this polarizability affects the nucleophilicity? This we need to understand. See, if I talk about this sigma bond, always we have a sigma star orbital in which the nucleophiles attach. Like we have a pi bond, then we have a pi star orbital. Similarly, if we have a sigma bond, we have a sigma star orbital. So what is happening here? This nucleophile is attacking into the sigma star orbital and the living group is being eliminated from here. Okay. So now what happens with the large size anion and with a small size anion? To understand this, let's suppose, have you played basketball? I hope so, or you must have watched it at least on television. Let's suppose this is a basket here. This should be a net, but it will work here. And there are two men, one a very small size kid and one with a very large size. He has a great height, like usually basketball players have. Okay, these are the two men. I have given them a ball and they need to place this ball into the basket. What will happen? This small man will first of all come close to this basket, and then after trying about 10 to 15 times he will succeed in throwing this basket into the this ball into the basket. But since a large size man is who has very great height, his approach is very much higher as compared to the smaller one. So he will be using using this benefit of its approach, and he can easily pass the ball into the basket. So something like this works here also. What is going to happen if we have a substrate R and R, hydrogen and a X, and we have a sigma star orbital? Very fine, sir. Now what is going to happen? A smaller size anion, in order to attack into the sigma star, will come very much closer to the R groups, and because of this it is going to face hindrance. Whereas a large size anion, it has a benefit that it can get easily polarized. It means its shape can be easily deformated. It very easily attacks into the sigma star and the living group is eliminated. It means what you are trying to say, sir, a bigger size anion will comfortably attack into the sigma star orbital and the living group will be eliminated. Yes, that's the point I am trying to make it out here. Got it? It means I can say that bigger size anion directly bigger size anion we should write in a statement way, bigger size anion has more nucleophilicity. Nucleophilicity. I hope I have justified this statement in front of you and you must have got the concept how why we always say that ki if we have a bigger size anion, then its nucleophilicity will be very high. Why? Because it can be easily deformated, its shape can be easily changed. So without facing any hindrance, it can attack into the sigma star orbital and the leaving group will be eliminated. Whereas a small size anion, he need to reach to the sigma star orbital very close to the bulky R group, because of which it is going to face the hindrance. That's why its nucleophilicity is little bit less as compared to a bigger size anion. This is what about the concept. Got it? So now what about questions, sir? How in exam questions are going to be asked? Very good. Cam diary and spread pace. We are doing good. Yes, of course. I minus, BR minus, CL minus. This is the this may be one order. Now let's suppose question comes where it is asked to compare nucleophilicity. Okay. We have few nucleophiles like I minus, Br minus, Cl minus and F minus. Now arrange these few nucleophiles into the order of their nucleophilicity. And again we have, let's suppose, a methanol here, CH3OH, and a CH3SH here. And we have next example as let's suppose water here, and we have H2S here. We need to arrange them in the order of nucleophilicity. You will observe a pattern. Since if size is bigger, the nucleophilicity is going to be high. So what we are going to observe is down the group, when you are in a periodic table, when you move down the group, the size increases. Yes, if down the group size increases, then of course nucleophilicity is also going to increase. Nucleophilicity will also increase. So now it becomes very easy for us to answer such type of questions. So I minus will be of fifth group, bromine of fourth, chlorine of uh, third and fluorine of second. So I minus, Br minus, Cl minus, and this will be the order. Good morning Pragriti, good morning. Yes, very good. Very comfortably you can say that CS3 SH will be more nucleophilic because size of sulfur is more as compared to that of oxygen, and then again in H2S and water we can say that nucleophilicity of H2S will be higher as compared to that of water. Okay, so this may be an easy way to answer. Now this was our first factor, that was size. But many times you will not be able to answer or you will not be able to identify the order on the basis of size. Then you need to move on the second order. So you need to understand the chronology. First of all, you have to compare on the basis of size. When size does not give you, will not give you the answer, then you will move on the second factor, that is going to be your electronegativity. Got it? Now, what does electronegativity says? Tell me, what do you think how electronegativity and nucleophilicity are related? Tell me into the comment section. Those people who are seeing this lecture in the recorded form, I request you to do comments your doubt in the comment section so that I can also see, yes, you are there and you are seeing the lectures, and if you face any doubt, you can ask me there also. More electronegativity, less nucleophilic. Yes, very good. See, it is very much clear enough. If you have a center which is very electronegative, it means it is pulling its electron density very strongly. Correct? Its nucleus is pulling its electrons very strongly. So, its natural tendency to donate that electrons is going to be reduced. It means, straightforward, I can say that if we have higher electronegativity, then of course the nucleophilicity is going to be reduced. Nucleophilicity and electronegativity will be inversely proportional to each other. In order to understand in a better way, we will be taking few examples also. Let's suppose we have few anionic centers like CH, C minus, and we have CH2 double bond C minus. We have, let's suppose, OH minus, and we have, let's suppose, F minus. Now we have few nucleophiles here where we need to arrange them into the nucleophilicity order. Can you do that? Fluorine less than ClBr. Tell me. See what happens. You can say, so this anion is on a carbon center, this is on a carbon center, this is on an oxygen center. So can't we apply the size factor here? Along the period also, when we move from left to right, the size get decreased. You may say that. See what happens in organic chemistry, we generally consider the size along the period as same. Or you can say that actually what is observed when we move down the group, the factor which is contributing towards the nucleophilicity is size, and when we move along the period, the factor which is contributing towards the nucleophilicity is actually your electronegativity. So we say that in organic chemistry, we can write a note here. In organic chemistry, along the period, we consider size as same. These are the small things which we must be aware of. It means along the period, the factor which is very important is your electronegativity. Now, since the size factor is same, we need to arrange these four anions into the electronegativity order. You must know that fluorine is the most electronegative element in the whole periodic table. So F minus is going to be at the first if we compare the electronegativity. Then comes your OH minus, then comes your CSC triple bond minus, and then comes your CH2 double bond C minus. Correct? This is the order for your electronegativity. So what will be the order for nucleophilicity? Very easy. We can just simply reverse this order. So the nucleophilicity becomes CH2 C minus. Okay. Few of you may have not understood about this. See, this carbon is your sp hybridized and this carbon is your sp2 hybridized. So there's a difference of percentage S character. What happens is percentage S character is directly proportional to electronegativity. Higher is the percentage S character, higher is the electronegativity. So I have used this basic concept which we generally study in general organic chemistry, that is GOC, that if we have a sp hybridized center, its percentage S character is 50%. That's why its electronegativity will be also higher. So comparing the nucleophilicity, we will be having CS, C triple bond minus, and then OH minus, and then F minus. This will be the complete nucleophilicity order. Now moving ahead, I will be giving you one more question. Let's see what you do in this. You have CH, C triple bond minus. You have CH2, CH minus. You have NH2 minus, and you have OH minus. Be quick and tell me the order for nucleophilicity. Yes, very good, Cam Diary. Tell me fast, what should be the order? What order we can expect here? See, talking about electronegativity, we will first see what is the order. we have a carbon which is sp hybridized, we have a carbon which is sp2 hybridized. But since they both are carbon, it means we are dealing with second period elements. Nitrogen and oxygen are also from the second period. It means size is not going to work. Again, we will come back to our electronegativity. Correct? So in electronegativity order, we should write that OH minus is most electronegative. Then you can say, sir, nitrogen is more electronegative. Then you can say, sir, carbon, which is sp hybridized, is more electronegative. And then you can say, sir, sp21. Now, tell me, do you support this order or you are against this order? Is there something wrong here? Other people who are watching watching the lecture, you can also contribute in the comment section. You can also speak out. You just need to write yes or no. Tell me. A key D. No sir. Okay. See, there is a small concept of modified electronegativity. What is this modified electronegativity, sir? We have not heard it. We generally cover this topic into general organic chemistry only. Modified EN, electronegativity. This say talks about 2 points. Point number one, a nitrogen which is sp3 hybridized is is less electronegative. Remember, it is less electronegative from any carbon. In general, what we study is nitrogen center is more electronegative than carbon, but if we have hybridization contribution also, sp hybridized carbon defeats nitrogen if which is sp3 hybridized in electronegativity terms. And the second point which is important is similar to nitrogen and carbon, oxygen which is your sp3 hybridized is going to be less electronegative than a nitrogen which is your sp hybridized. So this is also an important factor. Okay, so take care of these points also. So the correct order for electronegativity should be this order. We will put it in a box and we will do criss and cross. Okay. So the correct order should be OH minus and then CSC triple bond C minus and then comes your CH double bond CH minus. Okay, sorry. Then comes your nitrogen, that is NH2 minus, and at last comes your CH2 C double bond CH. Okay, so I am not going into detail of this. If you want to have a look of detail, then please refer general organic chemistry lectures where I have covered about this modified electronegativity when we were discussing about acidity, if you remember. Okay, if you are new to this channel, go and explore the general organic chemistry lectures where I have covered these things into a very detailed manner. Okay, so this is going to be the order for your electronegativity. So of course the nucleophilicity becomes second one highest, and then and then NH2 minus means the third one, then your first one, and then your fourth one. This will be the order for your nucleophilicity. Got it? How many of you are aware about this concept? Sir, when you restart reaction mechanism playlist. Sir, when you restart. We have just started this reaction mechanism. That is, this is our first lecture only. Okay, AKD. बहुत बढ़िया प्रगति, एक्सेलेंट. तो उम्मीद करते हैं आपको वहां से बहुत कुछ समझने को मिला होगा. That lectures will be helping you out in the basic portion. Now you need to build up your concepts over that basic portion which you have understood now. Okay, that are going to help you throughout the organic chemistry. So this is how we compare the nucleophilicity by using our second factor, that is electronegativity, And then finally, we can also compare on the basis of stability. What do you think? How stability can affect any center nucleophilicity? What's your point of view? Bahubali is saying that please complete every topic of reaction mechanism. If your response is good enough, Bahubali, I will definitely cover each and every topic of reaction mechanism. Okay. Now, what about stability? What do you think so? How stability can affect the nucleophilicity? See, what we observe is if a center is very stable, let's suppose its stability is very high. So its nucleophilicity is going to be very low. Why? This is very easy to understand. Let's suppose I give you 10 crore rupees today only. Then will you be preparing for CSIR net anymore? Tell me. Will you or will you not? Tell me in the comment section. If I give you 10 crore rupees just now, will you drop your plan of preparing for CSIR net or still you will be preparing for exam? Cam Diary saying no. See, that thing works here also. If you are very stable in life, if your stability is very high, then why you are going to attack on some center? Correct? So, if the stability is high, it means it is not going to attack at any center and its nucleophilicity is going to be very less. So that's a very simple thing which we can understand. If center is very much stable, its nucleophilicity, its basicity, or we can say its reactivity is very less. Now, in order to understand, we will take some questions also. If we have OH minus, if we have CS3COO, we call this as acetate ion, and if we have a phenoxide ion. Okay. Now, you need to tell me what will be the nucleophilicity order if I am talking about A, B, and C. Tell me, what will be the order? Yes, mostly will drop. Biggest motivation is money. Correctly said. Tell me first, what should be the order for nucleophilicity? A, B, C, A, C, B, A, or anything else? Whether B center is more nucleophilic or whether C center is more nucleophilic, this might be problematic for you. See, if we talk about size factor, they all are from second period only. It means size is not going to work anymore. If we talk about the second parameter, that is electronegativity, so we have all three as oxygen, that is also not going to work here. Now what we need to apply is the third factor, that is stability. Now stability says that if this anion does resonance, so we can draw its resonating structure. We have CS3, O double bond O and an once it does resonance, this O minus this O minus will be present here and double bond O here. Correct? And similarly, this can also perform resonance. So the resonating structure will look like this. Now, what happens for a carboxylate anion? For any carboxylate anion, the anion is present on a very electronegative center, that is oxygen. And once it does resonance, it again comes on a center which is very highly electronegative, that is oxygen. So this type of resonance is very effective one. This type of resonance is very stable one. Whereas in the phenoxide, this anions once does resonance comes on a carbon center and carbon is not that electronegative as compared to oxygen. You can also say that, sir, one may say this anion is going into a extended conjugation, but that is not a major factor which will contribute here, since this type of resonance where oxygen is an electronegative center and anion after doing resonance is again formed on the oxygen center is very effective. So this is going to be the most stable one. So if I write the stability order, the order should be something like this. Uh, B anion is very much highly stable, and then comes your C, and then comes your A. So the nucleophilicity order is going to be, we need to reverse this order. So A, C, and then B. Did you got the concept why I have written this order as ACB, not ABC? How many of you have got this order? Tell me in the comment section. Use your own emojis to express your feelings. Tell me fast. Okay, so this is a very small example. We can do other examples also. For example, let's take a few more anions where we need to compare the nucleophilicity. We have O minus, and at one center I have taken as S minus as center. We have again a phenoxide ion, but we have few NO2 groups also attached here, and again a phenoxide ion with only one NO2 attached here. Can you tell me what will be the nucleophilicity order for A, B, C and D? Tell me fast. Arrange them into the increasing or decreasing order. If we have A, B, C, D, four nucleophiles, what should be the order for nucleophilicity? Bahubali saying, sir, A, B, D, C. Okay. Think again. Don't be in hurry. Spread piece is saying BADC, BADC. Very good. See, the first factor which you need to compare is size. So size says that sulfur has a very large size. So its nucleophilicity will be very high on the basis of size. I always say go into the chronology. How can you miss the sulfur center? So according to size, B is on the top of the list. Size has decided that B center is very highly nucleophilic. Rest all are same in size because all are the oxygen center. Electronegativity also same. Now the third factor which will contribute is the minus M effect of these NO2, and which will be stabilizing the anions. So the most stable one will go at the last. So C is very highly stable, so its nucleophilicity will be least. Then comes your D, and then comes your A. So the correct order for nucleophilicity should be BADC, where B is on the top because of the factor that is called as size, and ADC has been compared on the basis of stability. Did you got the concept? This type of questions are asked in the exams, and if I remember, this was an IIT JAM exam question. So this basic questions may be asked into NET, GATE, any exam if you are preparing for. Okay. So in this lecture we have learned about what are the factors which can affect the nucleophilicity. Now the last factor will be hindrance and the solvent, which I will be covering on the next lecture. For this, I am closing this lecture here only. Thank you so much everyone, and we will meet again uh, sharp at 9 a.m. Remember the time, sharp at 9 a.m. daily, in order to complete this topic of reaction mechanism. Especially this is for the students who are facing Hindi as a barrier. So this complete lecture series will be in English only. Next lecture will be tomorrow 9 a.m. sharp. Okay. So I have left for now. I will be beginning from here only in the next lecture. Okay. Thank you so much everyone. Take care. Bye bye. Let's meet tomorrow, and do leave your comments into the comment section who are watching these videos in the recorded version. Thank you so much. Take care and happy learning.